Hello and welcome. Tonight we are beginning a journey. Find a place where you can be comfortable, where the sounds of the world can fade into the background. Let your breathing slow down and feel the tension release from your shoulders. We are not traveling with a ship, but with our minds setting out into the deep, quiet expanse of the cosmos. Our goal is not speed, but understanding and a sense of peace. Let's imagine our starting point. We are leaving the familiar blue of Earth far behind. We are drifting weightless in the profound velvet darkness of space. Right now, we are 3 astronomical units from the Sun. An astronomical unit is the measurement we use for the vast distances in our solar system. It is the average distance from the Earth to the Sun, about 93 million miles, or 150 million kilometers. So we are 3 times that distance. We have traveled far past the rocky red world of Mars and the tumbling highway of the asteroid belt. From this vantage point, the Sun is no longer the brilliant warming presence we know. It has shrunk in the sky. It is still the brightest star, a magnificent piercing point of light, but it is no longer a disk of overwhelming warmth. It is a distant diamond. Out here, the cold is absolute. It is a stillness that defines everything. The temperature is hundreds of degrees below zero, a cold that freezes not just water, but gases. The silence is perfect, a complete and total absence of sound. And yet, as we float in this deep freeze, we see something. We are not alone. In the darkness ahead, there is an object. At first, it looks like just another piece of space debris, a dark, lonely mountain of rock and ice tumbling slowly on a long journey. But as we get closer, we realize that something impossible is happening. This object is not still. It is not dormant. It is surrounded by a faint ghostly cloud, a shimmering halo of gas and dust that glows faintly in the distant sunlight. It has a tail, a delicate wispy stream of material stretching out behind it, pushed away by the sun's faint pressure. This object is active. It is breathing. Breathing. Our instruments would tell us something astonishing. This object is venting gas into space. The primary component is water in the form of vapor, and it is not a small amount. Every single second, this traveler is releasing 40 kilograms of water vapor into the void. Imagine 40 large bottles of water instantly vanishing into mist every single second. And that is the mystery, that is the paradox. Because out here at 3 times Earth's distance from the Sun, the laws of physics are clear and harsh. The Sun's energy is too weak. In this profound cold, water does not become a gas. It does not even become a liquid. Water is a rock. Water ice is as hard and as stable as granite. A normal comet, one of our own born in our solar system, would be completely silent here. It would be a dormant, frozen block, saving its spectacular show of gas and dust for when it dives much closer to the Sun's fire. Its water would be locked away, frozen solid. But this one is awake. This one is different. It is breaking the rules of our solar system. So what is this strange, impossible visitor? Scientists have given it a name through I-Atlas. That single letter I in its name is the key to the entire mystery. It stands for interstellar. This object, this dark mountain of ice and dust, is not from here. It was not born with our Sun. It was not created alongside Earth or Mars or Jupiter. It is a true visitor, an immigrant from the deep, unimaginable darkness between the stars. It is an alien in the most literal sense of the word. It is only the 3rd such object we have ever confirmed in all of human history. The 3rd time we have ever looked at something in our skies and known with certainty that it has come to us from another solar system. But its identity is only the beginning of the story. The true wonder of this object is its age. Our Sun, our Earth, and our entire solar system are what we might call middle-aged. We have been here for about 4.6 billion years. Astronomers, by studying the light and composition of this visitor, have estimated its age. 3i Atlas is believed to be between 7 and 10 billion years old. Let that idea settle in your mind. This small dark traveller was already wandering through the galaxy before our Sun even existed. It was formed billions of years before the Earth itself. It was born in a different solar system circling a different star, a star that is almost certainly long dead. It is a fossil from a star system that formed in the early youthful days of our Milky Way galaxy. This is why its journey to us is so profoundly important. This is not just a comet, it is a time capsule. It is a message in a bottle thrown into the cosmic ocean billions and billions of years ago, carrying the chemical history of its birth. It carries the ancient water, the dust, and the organic molecules from a star nursery that collapsed and died long before our own. When we study it, we are looking at the raw ingredients that formed worlds somewhere else long ago. We are looking at a piece of our own galaxy's deep ancient past. Think of the journey it has taken. born 10 billion years ago, perhaps pushed from its home by the gravity of a giant planet or a passing star. It was cast out into the lonely darkness, beginning a journey that would last for eons. It has drifted through the vast empty arms of the galaxy, passed through colourful nebulae, and witnessed the birth and death of countless stars. And now, after all that time, its path has by pure chance crossed ours. It has drifted into the light of our sun. The reason it is so active, the reason it is breathing out water in the deep cold, is because it is so ancient. It carries types of ice like frozen carbon monoxide and nitrogen that are far more volatile than water. In our own comets, these ices have mostly boiled away long ago, but in this ancient relic they remain. Even the faint weak sunlight this far out is enough to make those volatile ices boil. As they turn to gas and erupt from the surface, they are so powerful that they blast the heavier ancient water ice out into space with them. We are watching a ghost from the dawn of the galaxy, a traveller telling us a story not of our home, but of a home. It is a beautiful reminder that the universe is vast, ancient, and filled with impossible, wonderful things. As our world turns, as you settle into comfort, and your breathing deepens, there are eyes that never close. They are not human eyes. They are the wide, unblinking glass lenses of our greatest telescopes pointed outward, forever peering into the great silent dark. They are our watch towers. High in the mountains of Chile, in the vast dry quiet of the Atacama Desert, one of these sentinels keeps its vigil. The air there is so thin and so clear, it feels as though you could simply reach out and touch the stars. This robotic system is named Atlas. Atlas is not designed to look for grand, beautiful nebulas. It is not trying to find the faint light of the universe's dawn. Its job is more urgent, more personal. Atlas stands for the Asteroid Terrestrial Impact Last Alert System. It is a guardian. Its programming is simple: scan the entire sky night after night and look for anything that moves. It hunts for the small, dim, and often dangerous rocks that drift through our solar system. It is our planetary alarm system designed to find any object that might be on a path to come too close to home to give us a warning, a last alert. For years, its work has been a steady, predictable rhythm. It finds an object. The computers track its path. They see the gentle, steady pull of our sun's gravity bending its journey. It is almost always a familiar story. Another piece of rubble from the asteroid belt or a distant icy comet falling inward from the cold darkness. They are all members of our family, caught in the same gravitational embrace as our own planet. But on July 1st, 25, the routine was broken. The automated system flagged a new object. It was incredibly faint, just a tiny pinprick of light moving against the backdrop of fixed stars. At first, it was just another designation, another number in a vast digital catalogue. But as Atlas and other telescopes watched it over the next few nights, the computers tried to calculate its path. And they failed. The calculations wouldn't resolve, the numbers didn't make sense, because the computers were all trying to fit the object into a familiar orbit, a path that belonged to our solar system. Everything that is part of our solar system, from the great planet Jupiter to the tiniest grain of dust, travels in a closed path. You can think of it like a racetrack, a long, stretched-out circle called an ellipse. Some are fast, some are slow, but they all complete the loop. They are bound to our sun. They always come back. This new object was not on that racetrack. Its path was different. The math finally revealed the truth. The object's path was not a closed circle. It was an open curve, a shape that scientists call a hyperbola. This wasn't the path of something captured by our sun. This was the path of something that was just passing through. Imagine throwing a ball high into the air. You know it will come back down. Gravity is pulling it, binding it to the Earth. That is a closed path. Now imagine a bullet fired from a cannon miles away with so much speed that it streaks across your vision for just a second and then vanishes, never to return. It is moving too fast for gravity to catch it. This object was that bullet. It was moving at an incredible speed, so fast that our sun's gravity could barely bend its path, let alone capture it. It was a visitor. The word for this is interstellar. It means between the stars. It's a simple word, but the meaning is one of the most profound we have ever had to consider. This small speck of light was not born here. It did not form from the same ancient cloud of dust and gas that created our Earth, our sun, and all the planets we know. This object was a traveller, a messenger from an entirely different star system. Its journey had begun perhaps billions of years ago, in a place we can only and will only ever imagine. It was likely born in the swirling disk of ice and dust around a completely different sun, a star hundreds, perhaps thousands of light years away from us. For eons, for a time so long, It makes all of human history seem like a single breath it drifted. It moved through the vast, cold, empty space between the stars, a silent, frozen pilgrim in the interstellar void. It passed through darkness we cannot comprehend, lit only by the faint, distant glow of other star systems. And now, after a journey of unimaginable length and loneliness, by pure blind chance, its long path had finally crossed ours. It was the first time in human history that we had ever seen a physical object from outside our home. When we hear the phrase visitor from space, our minds are trained by stories to jump to one thing: aliens. We think of ships of signals of intelligence. But this object was not a ship. It showed no signs of technology, no messages, no signs of life. And in many ways what it was is so much more powerful, so much more fascinating. It was a natural object, a piece of rock or ice or both. It was a sample. Think about what that means. We spend billions of dollars to build robotic probes, our own messengers, and we send them out on journeys that take decades just to get a tiny glimpse of the planets in our own neighborhood. We strain our greatest telescopes to catch the faintest light from worlds orbiting other stars, trying to guess what they are made of. And here the universe, in its infinite and random generosity, had sent a piece of another world to us, a free sample delivered to our doorstep. It was a time capsule from an unknown place, a fossil not of life but of a different creation. It was a tangible physical piece of a puzzle from a star system that we will never ever visit. The discovery sent a quiet, powerful shockwave through the world of science. The race was on. This fleeting guest was not staying. It was already on its way out, heading back into the void. We had only a few short weeks. Every telescope that could be pointed was pointed at this tiny ghost. What could it tell us? What secrets did it carry from its distant alien sun? The universe had just knocked on our door, and we were listening, desperate to find out who was there. Let us continue our journey, settling deeper now. Let your breath slow, in and out. We have met our traveller, this silent guest journeying through our solar system, but to truly know it, we must paint its portrait. Not with paint, but with neon numbers and with wonder. Let us try to see it together in our mind's eye. The first brushstroke is its bay. Imagine a mountain. Not a mountain on Earth rooted in stone, but a mountain floating in the endless night. This is the scale of our visitor. We believe it is between 2 and 6 kilometers wide. Imagine the city you live in or the town. This object could be large enough to cover it completely. A jagged, uneven shape, a peak of ancient ice and rock tumbling slowly end over end. It has no lights, it has no sound, it is just there. A piece of the original ancient solar system preserved for billions of years in the deep cold. And it is substantial. Our estimates place its mass at around 30 billion tons. This number is so large it feels meaningless. It floats past our understanding, so let's try to hold it another way. Think of the Great Pyramid of Giza, a wonder of human engineering, a mountain of stone. This traveller, this comet, has the mass of hundreds of those pyramids, all that weight, all that substance moving with impossible grace. Or think of the largest ships we have ever built, vast aircraft carriers, cities of steel. This single object weighs more than thousands of them combined. It is a true giant, a titan of the void, and it is entirely, profoundly alone, and yet it does not linger. This titan is in a hurry. It is moving at a speed that defies our earthly intuition. It travels at 210,000 kilometers every hour. A speed not of travel, but of escape. Let's make that real. In the time it took for you to take that last slow breath, in and out, it has already crossed hundreds of kilometers. In the single second it takes for your heart to beat, 1, it has travelled 60 kilometers. 60 kilometers. That is the distance of a marathon, and then stones, then some. Travelled in a single silent tick of the clock. A mountain of rock and ice, heavier than all our pyramids, moving faster than any bullet, faster than any human-made machine. A silent cosmic cannonball streaking through the dark. Now as you lie here safe and warm, a thought might flicker in your mind. A body that large, that heavy, moving that fast. It is the stuff of nightmares of movies about the end of the world. Is it a danger? Is it coming for us? And here you can let your shoulders relax, you can let your muscles soften, because the answer is a clear and wonderful no. It is not a threat. We have watched it. We have mapped its path. Its orbit is stable, and it will pass us by at a vast, safe distance. It is a ship passing in the deep ocean of the night. We are simply watchers on the shore, safe, secure. You can let that worry dissolve. It is not a fear. It is a marvel, a wonder to be contemplated from afar. So just breathe, you are safe. But this marvel, this safe distant wonder is also a profound puzzle. And this is where our journey takes a turn. This is where the quiet hum of the universe becomes a question. We think we know comets. For centuries we have called them dirty snowballs, a simple name for what we thought was a simple object. Our story has always been this. A comet is a ball of ice and dust. It spends most of its life in the deep frozen outer reaches of the solar system. Then something pulls it inward toward our sun. As it gets closer, the sun's light, its warmth begins to work on the ice. The ice does not melt. It sublimates. It turns directly from a solid into a gas. This gas, this vapor, bursts from the comet's surface, streaming away into space. It carries dust with it, and this cloud of gas and dust creates the beautiful glowing coma, the head of the comet and its long streaming tail. This is the rule. This is what comets do. And our traveller at first seemed to be obeying. Just last month, in the quiet of October 2025, we turned a powerful eye toward it. The Swift Observatory, one of our guardians in space, was watching. It was hunting for a specific chemical signature, the ghost of water. Something called hydroxyl. It is what water H2O becomes when the sun's harsh light breaks it apart. And Swift found it. A powerful, unmistakable signal. Our mountain in space is shedding water. It is breathing a cloud of vapor into the void. A lot of water. Our instruments are precise. They tell us it is releasing 40 kilograms of water every single second. Imagine 40 large bottles of water just gone every second. A river appearing from nowhere in the blackness of space. And here the story breaks. The rules are broken. This is the puzzle that is keeping scientists gazing at their screens even as you begin to gaze into your dreams. The problem is sunlight, or the lack of it. Our traveller is still very far from the sun. It is at a distance of 3 astronomical units. It's a simple term, or an astronomical unit is the distance from the Earth to the sun, so this object is 3 times farther from the sun than we are, 3 times. Out there, the sun is just a small bright star. The sunlight that falls on the comet is incredibly weak. It has only 11%, just a fraction of the power, the intensity that we feel here on Earth. It is a faint, cold light, and that faint light is not enough. All our physics, all our understanding of heat and ice tells us that this light is too weak. It simply cannot be the engine driving this display. It cannot be turning that much ice into gas. It cannot be creating a 40 kilogram per second river of vapor. And yet the river is there. We see it. We have measured it. This single observation, this quiet, undeniable fact, it challenges our understanding. It means our simple story, our dirty snowball model is incomplete. It's wrong. Or it means something else is at work, something hidden, something new, a different kind of engine, a different kind of fire. And so as we watch this ancient mountain heavier than all our pyramids racing through the silent dark, we are left with a single profound question. A question that hangs in the velvet blackness between the stars. If the sun is not doing this, then what is? How is this possible? This is not a question that demands an answer from you. Not tonight. For you it is just a story, a mystery to curl up inside. A puzzle to hold lightly in your mind as you sink deeper and deeper into comfort and rest. The universe is whispering a new secret, a new riddle. And you're here just to listen, to drift on the edge of this great unknown. Let the question go, let it float away. How? What? As you let go completely and drift into sleep, so there it is, a faint, impossible traveller moving through the darkness. This Object 3-ish Atlas has presented us with a profound riddle. It is active, but it is too far from the sun. It is moving, but in a way that seems to defy our expectations. When you find a mystery like this, the first step is to investigate, to ask the right questions. And the first question was, what is driving it? In the quiet halls of universities and observatories, the first ideas began to form. These are the first gentle guesses, the hypotheses. The most obvious guess, the one our minds jump to first, is water. That is what comets do. They are our solar system's great dirty snowballs. We are familiar with them. We understand them. When they get close enough to the sun, the sunlight, even if it's weak, heats the surface. That water ice doesn't melt in a vacuum. It skips melting entirely and turns directly into a gas. This process is called sublimation. Imagine a cloud of steam, but instead of coming from a kettle, it's erupting from a mountain of ice. This cloud of gas, this coma, expands and the pressure of it escaping pushes the comet. It's a tiny natural rocket engine. It's what gives a comet its motion, its tail, its life. But 3 Atlas was too cold. It was still in the deep, deep freeze, way out past the orbit of Saturn where the sun is just a bright star, not a source of real heat. The sunlight reaching it was far too weak to boil water ice. It was like hearing the sound of a splash in a room that was frozen to 50 degrees below zero. The sound just didn't match the environment. So if it wasn't water, what else could it be? Maybe it was just pushing out tiny, fluffy particles of ice like a slow, steady dusting, or maybe it was a different kind of ice, something far more delicate, something that could turn to gas at much, much colder temperatures. The prime suspects were two gases we know very well. One was carbon monoxide, the other was carbon dioxide. You know carbon dioxide. It is the gas we breathe out. It's the fizz in a soda. In its solid form, we call it as dry ice. Dry ice is vastly more volatile than water ice. It turns to gas at incredibly low temperatures. If 3E Atlas were a comet made not of water snow but of dry ice, then it would be active this far out. It would be fizzing away gently as it felt the first faint whispers of the distant sun. This was a good theory, but how do you prove it? How can you possibly know what something is made of when it is billions of miles away and is nothing more than a faint, blurry dot of light? The answer is one of the most beautiful and powerful tools in all of science. It is called spectroscopy. It sounds complex, but the idea is simple and it is a pure magic. Think of it as a way to read a chemical fingerprint. Every element, every molecule in the universe, water, carbon, iron, oxygen, absorbs and emits light in its own unique specific way. It's their signature. When we capture the faint light from 3E Atlas and pass it through a special lens, a prism, we can spread that light out into a spectrum like a rainbow. But it won't be a perfect smooth rainbow. It will have tiny dark lines in it. Gaps. These gaps are the fingerprints. They are the shadows cast by the molecules in the comet's coma. By reading those gaps, we can tell with absolute certainty what gases are escaping. There was just one problem, a massive problem. 3E Atlas was impossibly faint. It was a tiny speck of darkness against the total blackness of space. The light we were receiving from it was just a few photons, a few drops of light in an ocean of night. No single telescope on Earth was powerful enough to gather that light and read the fingerprint. And so humanity did something wonderful. We assembled an army, a telescope army. It's a quiet kind of investigation. Not one of loud sirens, but of silent patient waiting. Astronomers booking time months in advance on these incredible billion-dollar machines. In silent orbits above the Earth and on the darkest mountaintops below, we pointed our greatest eyes at this one single tiny spot. We called in the James Webb Space Telescope. Its giant golden honeycomb mirror is the most powerful eye we have ever built. It is designed to see in infrared light the light of heat. It is perfectly tuned to find the faint cold glow of molecules like water and carbon dioxide shivering in the cold. Its mission was to find the fingerprint. We aimed the legendary Hubble Space Telescope at it. For decades, Hubble has been our faithful window to the cosmos. Its mission was different. It wasn't looking for the fingerprint, but it was looking for the shape. It would take the sharpest possible pictures of the coma, that fuzzy atmosphere, to see its structure. Was it smooth? Was it coming from one bright spot, a single geyser? We used new powerful tools like SphereX, an instrument designed specifically to do that detailed spectral analysis to hunt for the chemical shadows. And on the ground, on the high, dry volcanic peaks in Hawaii, and the desolate, clear-aired mountains of Chile, the giant mirrors of our greatest ground-based observatories also swiveled in the dark. They too stared into the void, gathering every single photon they could, night after night, adding their data to the pool. It was a global effort, a collaboration of scientists and engineers all united by that one simple question. What are you? The data streamed in, faint signals buried in noise. Slowly, patiently, computers combined the images, stacked the signals and cleaned the data. And then they found it. The fingerprint was there, the dark lines in the spectrum. The telescopes led by James Webb had found the gas that was pushing this object. It was, as some had guessed, carbon dioxide. But that was not the discovery. That was not the shock. The shock was the amount of it. In our solar system, comets are overwhelmingly water. They are dirty snowballs. They might have a little carbon dioxide trapped inside like bubbles in a frozen lake. But water is always the star of the show. Here, the data was unmistakable. The ratio was completely, utterly backward. For every 1 part water they could detect, there were 8 parts carbon dioxide. 8 to 1. Let that sink in. This wasn't a snowy comet with a few bubbles of dry ice. This was a comet made of dry ice with maybe a tiny bit of water ice mixed in. This was bizarre. It was unlike any comet we had ever seen. Think about the comets we know, Halley's Comet, Hale-Bopp. They are like chunks of frozen icy tundra rich with water. This object, 3I Atlas, was as if we had spent our entire lives studying trees made of wood, and one day a tree drifted by that was made of glass. The chemical recipe was wrong. This changed everything. Our comets, the ones from our Oort cloud and our Kuiper belt, were formed in a part of our early solar system that was rich with water. This object, 3I Atlas, must have been born somewhere else. Somewhere that was incredibly rich in carbon dioxide but strangely poor in water. The investigation had not solved the mystery. It had only made it deeper. It had given us a single impossible fact 8-1. This wasn't just a visitor. It was a clue, a chemical messenger, a ghost from a part of the solar system we didn't even know existed. Or, perhaps, wasn't from our solar system at all. So how do we solve this beautiful cold mystery? How does an object frozen to its very core send out a plume of water vapor weighing 40 kilograms every single second? The answer, it turns out, is wonderfully clever. And it begins by realizing we were looking at the wrong kind of ice. The faint sunlight reaching 3I Atlas, so weak and distant, was never enough to warm the water ice. Water ice is stubborn. It holds on to its solid form until the temperature gets much, much higher. But this visitor from another star, it isn't just made of water. Its surface is rich in something else, something far more volatile. Carbon dioxide. In our world, we know it as the gentle gas we exhale with every breath. We know it as the fizz in a cold drink, but in the desolate, deep cold of interstellar space, carbon dioxide freezes solid. We call it dry ice. And here is the secret: frozen carbon dioxide does not need much warmth at all to change. It doesn't even melt. It does something called sublimation. It turns directly from a solid straight into a gas. And the faint, weak sunlight at that enormous distance, it is more than enough. Let your mind drift to the surface of this dark traveller. It is not a smooth, quiet snowball. It is a cracked, ancient crust, and locked within it, just beneath the surface, is this vast reserve of frozen carbon dioxide. As 3 Atlas moves through our system, that weak sunlight, a mere whisper of warmth, begins to touch the surface. It penetrates the dust, it finds that dry ice, and the ice begins to turn to gas. But this gas is trapped. It is under the surface. Imagine the pressure inside a bottle of soda, shaken and unseen. A quiet, relentless pressure begins to build beneath the crust. The new gas pushes outwards, searching for any escape. It finds a weak point, a small fissure, a crack in the ancient ice. The pressure becomes too much, and in a silent, cold explosion, the surface fractures. The trapped gas bursts free. But it doesn't just vent gas. This explosion is powerful enough to throw shrapnel into space. It blasts chunks of the comet's own crust high above the surface. And what are these chunks made of? They are made of ordinary, stable, heavy water ice. These are the fragments that were mixed in with the dry ice innocent bystanders to the eruption. Now these pieces of water ice, some small, some large, are floating free in the total vacuum of space. They are no longer part of a giant cold object. They are small, exposed and surrounded by sunlight. Now the water ice sublimates. Now it turns to gas, releasing that enormous 40 kilogram per second plume that so puzzled us. The signal we saw wasn't the comet gently steaming like a kettle. It was the result of a chain reaction. A series of small pressurized geysers, all powered by carbon dioxide, which in turn blasted the real water ice out into space where it could finally evaporate. It's a beautiful, elegant solution. It explains the signal, the temperature, and the paradox. But as always in science, this answer simply opens the door to a much larger, more profound question. Why? Why does 3I Atlas have so much carbon dioxide? Our own comets, the ones born with our sun, have some, but not like this. This object is fundamentally different. Its chemical makeup is alien to us. And the answer to that question is perhaps the most wondrous of all. It has so much carbon dioxide because it was baked in a different oven. This is the metaphor astronomers use. Think of our solar system as one kitchen, one oven. When it first formed 4.5 billion years ago, it had a certain set of ingredients, a certain amount of hydrogen, of helium, of oxygen, of carbon. And it was set to a certain temperature, warmer near the sun, colder far away. All of our planets, our asteroids, our comets, they're all baked from that one recipe. They are all family, but 3I Atlas is not from our family. It was born in another kitchen. It formed around another star. The sheer amount of carbon dioxide tells us that its home system was a different place. It was likely much, much colder than our own system was during its formation, and it was clearly far richer in carbon. Its recipe was different. This is the true gift of 3I Atlas. It is the first time we have ever been able to do what scientists are calling galactic-scale comparative planetology. scale, sure. We are not just comparing Earth to Mars. We are not just comparing our sun to another star. We are holding a piece of another solar system in our hands. We are studying its chemistry. We are learning the ingredients that built worlds light years away. We are, for the very first time, seeing the chemical blueprint of an alien world. A message in a bottle not from another civilization, but from another creation entirely. And it just happened to wander by. And so we find ourselves watching this traveller as it fades back into the darkness. We watch it and we ask the simplest, most human question, how old are you? The answer is one that stills the mind and quiets the room. The best estimates, the ones that scientists quietly discuss when they try to model its journey, place its age somewhere between 7 and 10 billion years old. Let that number settle. 7 billion years. To understand what this means, we must look at our own home. Our entire solar system, our Sun, our Earth, Jupiter, Mars, all of it, is only about 4.6 billion years old. Our world, the only home we have ever known, the place where life began, is younger. It formed from a cloud of dust and gas after this object was already ancient. This visitor is not just a piece of rock or ice, it is an elder. It is a relic from a time before the Earth. It existed before the Sun stabilized into the star we know. It is a piece of a history so old we have no living records of it. It is a citizen of a galaxy that existed before ours was fully formed. When this Object 3 Atlas first came into being, our Sun was likely just a swirling cold cloud of gas, not yet a star. The very elements that make up our bodies, our oceans, and the air we breathe, many of them were still being forged in the fiery hearts of giant stars that would later explode. This traveller, it remembers that time. It holds the chemical memory of that ancient galaxy, a chemistry that might be subtly different from our own. When we speak of its age, we are not just talking about a number. We are talking about a different era of the universe, an era we can only glimpse with our most powerful telescopes by looking at the most distant faint lights. Where did it come from? It must have been born in a Milky Way that we would not recognize, a younger, wilder version of our galaxy. It formed in a distant solar system orbiting a star that has likely long since burned out and died. We can only imagine the chaos of that ancient stellar nursery. Perhaps it was a quiet sibling to other planets, but something happened. A gravitational nudge from a passing star, a push from a giant planet, a cosmic billiard shot that sent it flying. It was ejected from its home. It was thrown out into the great empty dark ocean between the stars. And there it began its true journey. A journey not of years or centuries or even millennia, but of billions of years. It became a wanderer in the deep cold. The silence of that journey is profound, floating through the void where the temperature is just a few degrees above absolute zero, the coldest possible cold. In this perfect unchanging freeze, nothing decays, nothing changes. It was, and is, a frozen time capsule. It carries the physical fingerprint of a time and a place that vanished long before our own world was born. Its long drift was a journey through true emptiness. For millions of years at a time, it would not have passed a single star. It was bathed only in the faint ancient glow of the cosmic microwave background, the leftover light from the Big Bang itself. It moved in a straight line, obeying only the faint collective pull of the galaxy. It saw nothing. It felt nothing. It was a suspended thought, a message in a bottle thrown into an ocean infinitely vast with no intended shore. The odds of it ever encountering anything, let alone a small warm solar system like ours, are so small they are difficult to even write down. And yet it happened. After an unimaginable span of time, pure chance brought it to our doorstep. It fell into our solar system. As it drifted closer to our sun, something remarkable happened. It woke up. The faint warmth of our star, a star it had never met, was enough to stir it. The ancient frozen materials on its surface began to turn to gas. It started to show signs of activity, a faint breath of gas, an unexpected push, a whisper from its deep frozen sleep. And this is the great mystery. This is the question that keeps us awake even as we seek rest. Why? Why is it still active? After 7 or 8 or perhaps 10 billion years, how can it still have this energy? Shouldn't it be a cold, dead, inert piece of history? Shouldn't all its volatile materials, its ice and frozen gases have been lost to the void eons ago? Physics as we understand it tells us this should be difficult. Over billions of years, even the faint starlight from distant passing stars should have been enough to slowly sandblast its surface, chipping away at its frozen reserves. The cosmic rays, the high-energy particles that zip through the galaxy, should have broken down its complex materials, It should have arrived here as a silent barren rock. But it did not. It arrived as a puzzle. It arrived with a hidden well of energy. It suggests that the universe is far better at preserving its history than we ever dreamed. There are a few possibilities we can drift upon. The first is that the void itself is the ultimate guardian, that the deep interstellar cold is such a perfect preservative that it truly completely stops time. In that darkness, 10 billion years might pass like a single night. It lost nothing. It was perfectly sealed, waiting for a single moment of warmth to reveal its secrets. We just happened to be the first star to greet it in all that time. If this is true, it means the galaxy could be filled with these frozen memories. Billions of them, drifting, waiting. It means that the history of the galaxy is not lost. It is merely sleeping, floating in the dark. But there is another thought, a different path. What if the object is ancient, but its journey is not? What if 3 Atlas is indeed 10 billion years old, born in the dawn of the galaxy, but it did not spend all that time wandering? Perhaps it lived a very long, very stable life in its home system, and then much, much more recently, perhaps only a few million years ago, it was finally thrown out. In this version of the story, it is not an ancient wanderer. It is an ancient refugee, freshly exiled, and we are just the first system it has visited. This would explain why it is still active. It simply hasn't been travelling long enough to lose its energy. This too tells us something profound. It tells us that even in ancient, stable solar systems, chaos can still win. That even after billions of years, a world or a piece of a world can be cast out. It reminds us that in the cosmos, nothing is permanent. For the longest time, we believed our solar system was a secluded island, a quiet garden enclosed by a vast empty wall. We looked at our 8 planets, our belts of rock and ice, and we thought, this is the model. This is how solar systems are. We were in our own way profoundly lonely, convinced we were a standard design, but with no others to compare ourselves to. But the quiet of space is deceptive. The vast ocean between the stars is not empty. It is a cosmic highway. And recently, very recently, we have started to receive visitors. These are not ships. They are not conscious messengers. They are travellers of rock and ice, orphans of gravity thrown from their own home systems and sent on journeys that last millions, perhaps billions of years. They drift through the endless dark, and by pure random chance, a few of them have tumbled through our small sunlit home. We have officially seen and confirmed 3 of these interstellar guests, and each one in its own way has completely shattered our assumptions. The first one arrived in 2017. It was given a beautiful name, Oumuamua. It means a messenger from the distant past arriving first. It was a fitting name because it was our first, and it was a mystery. It didn't look like anything we knew. Our solar system has 2 kinds of debris asteroids, which are mostly rock and comets, which are dirty snowballs of ice and dust. Oumuamua was neither. From the way its light flickered as it tumbled, we learned its shape. It was astonishing. It was long, perhaps 10 times as long as it was wide, a shape like a cigar or perhaps a thin, flat shard. We had never ever seen an object in space with proportions like that. It was our first clue that the universe has more imagination than we do, but the shape was only the first puzzle. The real mystery was its movement. As it looped around our sun, it sped up, it accelerated, pushing away as if something was giving it a gentle, invisible shove. This is normal for a comet. The sun's heat boils a comet's ice, creating a cloud of gas and dust around it, a coma and a beautiful tail. This outgassing of gas acts like a tiny rocket engine pushing the comet and changing its path. But Oumuamua had no coma, it had no tail, it was clean, it was just a dark reddish rock, pushing itself. It accelerated without any visible reason. What was it? A fragment of a planet that was torn apart, a dry, hardened husk of a comet whose ice had long since boiled away. Some even wondered if it could be an artificial object, a piece of alien technology tumbling silently through our system. We may never know. It is gone now, silent as it arrived, heading back into the void forever out of our reach. But it left us with a profound lesson. The galaxy is not just strange, it is stranger than we can possibly imagine. Then, just 2 years later, in 2019, we found another. We named it Comet Borisov. And at first, the entire scientific community breathed a sigh of relief. This one looked normal. It looked like a comet. It had a fuzzy cloud of gas around it. It had a long, beautiful tail. It was reassuringly normal. This was wonderful. It meant that other stars have icy bodies in their outer reaches just like our sun does. It suggested that the process of planet formation, the building blocks of worlds, might be universal. But normal is a relative term. When we looked closer, Borisov had its own secrets. We pointed our best telescopes at it and studied the light coming from its gas. Its chemistry was different. It was incredibly astonishingly rich in a gas called carbon monoxide. It had far, far more of this gas than any comet we have ever seen from our own solar system. This was a deep clue. It told us that Borisov was born in a very different place. A place much, much colder than where our own comets formed. Perhaps it was born in the deep frozen blackness around a small red star. Or perhaps it formed in a part of its home system where the chemical ingredients were just mixed differently. So Comet Borisov taught us a second, more subtle lesson. Yes, other stars make comets, but they don't have to make them like we do. The ingredients may be the same ice gas dust, but the recipe is different everywhere. And that brings us to the third guest, the one that passed us just this year, 25, the object called 3I Atlas. This one was different all over again. It wasn't a strange dry rock like Oumuamua, and it wasn't a gassy, cold-born comet like Borisov. It was something ancient. As it neared our sun, it began to glow, and the light it gave off told us its story. It was loaded with carbon dioxide, dry ice. But as it warmed, it also began to release water. A lot of water. This wasn't just a comet, it was a water producer. It was a time capsule, a frozen piece of a system where the building blocks of life were being delivered. We realized we were looking at a piece of an ancient construction site. It was the kind of object that in our own solar system billions of years ago would have crashed into a young dry Earth, delivering the very water that now fills our oceans. It was a messenger of life. So let us rest and think about this. 3 visitors, 3 postcards from the stars, and not one of them was the same. The first was a mystery, a scout so strange we still debate what it was. The second was familiar, but with a different chemical recipe. The third was an ancient water bringer, a piece of a forming world. 3 visitors, 3 completely different stories. This is the conclusion, and it is vast. It tells us that the galaxy is not a factory. It is not an assembly line that builds solar systems all looking the same. It is a garden of infinite wondrous and surprising variety. Every star system is a unique experiment. Every one has a different chemistry, a different history, a different architecture. As we drift off to sleep, we can imagine those other systems. Worlds of high carbon monoxide, worlds where planets are built from different kinds of ice, worlds that produce strange tumbling shards of rock. We are not alone in our existence. The galaxy is teeming with variety, with different kinds of normal and different kinds of strange. And we are just beginning to receive the mail. Sleep now and dream of the messengers floating in the deep. The discoveries of Oumuamua and Borisov were like finding 2 strange, beautiful seashells on an infinitely long beach. They were thrilling, shocking, and they forced us to realize that the ocean we thought was empty is actually full of things, messages from far away. But the truth, the statistical reality is that Oumuamua and Borisov were not the first and they were not the last. They were just the first 2 we were able to see. Our current telescopes, powerful as they are like looking at the sky through a narrow straw. We only see what happens to pass directly in front of our tiny field of vision. The calculations are humbling. Based on the 2 we found in such a short time, astronomers believe that thousands, perhaps even tens of thousands of these interstellar objects are passing through our solar system right now. They are moving silently in the dark between the orbits of Mars and Jupiter, or perhaps swinging out wide past Neptune. They are too small, too dark, and too far away for us to notice. We are standing in a cosmic rainstorm and we have only just managed to catch 2 drops. This is all about to change. High on a mountain in Chile, under some of the clearest skies on Earth, a new giant eye is being built. It is called the Vera Rubin Observatory. This observatory is not like others. It is not designed to stare at one faint galaxy for weeks on end. It is designed to do something much more ambitious. The Vera Rubin Observatory will be a motion picture camera for the entire night sky. Every few nights it will scan the whole sky available to it over and over again. It will create a map of unprecedented detail. But more than that, it will compare this new map to the map it made a few nights before. It is designed specifically to find things that move or change. And this is where our story shifts. When this observatory goes online, our relationship with these visitors will change forever. We will shift from a mindset of rare events to one of routine detection. Finding an interstellar object will no longer be a once-in-a-decade global news story. It might become a weekly occurrence. Astronomers will have to build new automated systems just to keep up sorting and flagging the new arrivals. We will begin to build a catalogue, a library, the Great Library of Interstellar Objects. This library will be our first real census of the galaxy's nomadic population. We will finally be able to answer simple questions that were, until now, complete mysteries. Are most visitors rocky like Oumuamua, or are they icy comets like Borisov? Do they come in all shapes and sizes? We will be able to trace their paths backward, pointing to the constellations they came from. We will build a map not of the stars, but of the invisible currents and highways that connect them. And this library will hold the clues to a much bigger idea. An idea so profound it borders on science fiction, yet it is a very real, very testable hypothesis. It is called panspermia. Pan means all and spermia means seed. The idea that life, or at least its essential ingredients, is not unique to Earth. We know that comets in our own solar system are rich in fascinating materials. We have visited them with space probes. We know they are full of water ice. We know they carry carbon dioxide. And most excitingly, they carry organic chemicals, the complex carbon-based molecules that are the fundamental building blocks of life. Amino acids, the components of proteins, have been found in meteorites. In our own solar system, comets and asteroids act like a delivery service, transporting these ingredients from the cold outer system to the rocky inner planets. Now let's apply this logic to the entire galaxy. We see comets like Borisov full of water and carbon being thrown out of their home systems. We see them journeying for millions of years through the cold, sterilizing vacuum of space. Then we see them enter our system. The idea of panspermia suggests that this is the galaxy's own shipping network, that these comets are transporting the chemical starter pack for life all across the Milky Way. They are the seeds, and planets like Earth are the fertile soil. This theory suggests that life didn't have to start from scratch on every single world. It just needed to start somewhere, and then the galaxy itself would have done the work of spreading the potential. This is galactic-scale material exchange. The galaxy is not a set of isolated islands. It is a single vast ecosystem sharing its chemistry. And this brings us to one last beautiful realization. For all of our progress, we are still trapped. We have found thousands of exoplanets, worlds orbiting other stars. We know they are there, but we cannot visit them. The nearest one is so far away that it would take our fastest current spacecraft over 70,000 years to reach it. We are like planetary scientists trapped on a tiny island, knowing there are continents just over the horizon, but with no boat to get there. But this new understanding of interstellar objects changes the game. If we cannot go to the exoplanets, we can wait, because the universe is bringing the exoplanets to us. Each one of these interstellar visitors is a sample. It is a piece of another solar system, a fragment of an alien world delivered directly to our doorstep. When we study the light reflecting off a rocky visitor, we are doing geology on a planet that orbits a star light years away. When we analyze the gases boiling off an icy comet from another star, we are sniffing the atmosphere and the ancient materials of a place we will never see. We are studying the building materials of alien worlds. We are no longer isolated. The universe is actively manging us samples. We are just now learning how to open the packages. We are just beginning to read the messages in these cosmic bottles. Messages that tell us about our neighbours, our origins, and our true place in a vast, interconnected and living cosmos. We have spent this time together breathing slowly and considering the journey of this traveller. We have imagined its long, cold sleep and its brief, fiery awakening. But now let us rest our minds on a different part of the story. Let us think about the people who saw it. Let us think about the incredible, intricate dance of human ingenuity that allowed us to even know this object existed at all. Because seeing it was not simple. It was perhaps one of the most difficult astronomical challenges ever attempted. The universe you see is mostly empty, dark and still. Our telescopes are built to look at things that are either very, very bright or things that stay in one place for a very, very long time. This allows us to gather light hour after hour, night after night, until a faint invisible smudge becomes a brilliant detailed galaxy. This visitor was none of those things. It was faint, a ghost in the darkness. It was fast-moving with astonishing speed against the backdrop of distant stars, and it was fleeting. It was a one-time show. There would be no second chances, no "let's look again next year." It was now or never. Imagine the moment the news spread. Not as a panic, but as a quiet electric current of human curiosity. In control rooms and observatories across our world, schedules were suddenly urgently rewritten. Astronomers who had waited years for their specific allotted time on a major telescope simply gave it up. They postponed their own life's work for a chance to contribute to this global communal effort. High in the bone-dry air of the Atacama Desert in Chile, giant mirrors turned in unison. On the sacred peak of Mauna Kea in Hawaii, instruments designed to look at the dawn of time were pointed at a newborn mystery in our own backyard. In the Canary Islands, surrounded by the vast dark Atlantic, more eyes turned toward this fleeting streak of light. It was a planetary fire drill for the sky. But even with all of Earth's power, we were looking through a shimmering, unsteady veil of our own atmosphere. To see it clearly, we had to use our eyes in space. We turned to Hubble, our old faithful companion. For decades, it has shown us the universe in stunning, sharp detail, and it did not disappoint. Hubble gave the object a face. It captured the crisp, clear edges of its structure, the shape of the cloud of gas and dust billowing away from it. It gave us the form. Then we turned to our newest, most powerful eye, the James Webb Space Telescope. Webb sees the universe in a light that our eyes cannot. It sees in infrared. It sees the light of heat. While Hubble saw the shape, Webb saw the energy. It could pick apart the faint glow and find the chemical fingerprints hidden within. It was Webb that could confirm without a doubt the complex molecules, the dust, the water. It gave us the chemistry. And there was Swift, a satellite designed as an alarm bell built to find the fastest, most violent explosions in the cosmos. Its wide-searching gaze caught the initial staggering data. It was Swift that first measured the plume. It was Swift that gave us that almost unbelievable number, 40 kilograms of water vapor. Every single second. Imagine a powerful fire hose emptying a swimming pool in just a few minutes, all erupting from a small dark object in the vacuum of space. Swift gave us the scale of its power. But the most beautiful part of this story, the part that speaks most to where we are and where we are going, comes from an unexpected place. It comes from Mars. While the teams on Earth were coordinating, someone had a brilliant, almost impossible idea. We have robotic scouts circling the red planet, the Mars Express from the European Space Agency, and the Trace Gas Orbiter. These machines were not built to look out at the stars. Their entire purpose is to look down. They are designed to study the thin atmosphere of Mars, to map its rusty canyons, to search for tiny trace gases. The challenge was staggering. The object they wanted to see, this fleeting visitor, was more than 10,000 times fainter than anything these orbiters were designed to look at. It was like asking a camera built only for bright sunny days to capture a single distant candle in the middle of the night. It was a gamble. The engineers had to rewrite the software, turn the spacecraft around, and point their delicate instruments away from their Martian home and into the black. They didn't know if they would see anything but static. They took the chance, they aimed, and they opened their eyes. The image they got back was not beautiful. It was not a stunning, colourful portrait. It was, to be honest, just a few blurry pixels of light on a dark background, a faint, insignificant smudge. But it may be one of the most profound images we have ever taken. Why? Because for the first time we had seen the same object at the same time from two completely different worlds. We had a view from Earth and we had a view from Mars. This is called stereoscopic vision. It is the same reason you have two eyes. It gives you perspective. It gives you depth. In that moment, with those few blurry pixels, we had done something new. We had performed multiplanetary astronomy. We were no longer just a species observing the universe from a single point. We had used the inner solar system as our observatory. And that is the true deep lesson of this feat. No single telescope could have done it. No single team or single nation could have unraveled the mystery. Hubble gave us the shape, Webb gave us the chemistry, Swift showed us its power, and our tiny repurposed robots at Mars gave us a second crucial perspective. It was only by bringing all these pieces together, by synthesizing these fragments of data, that a full rich picture emerged. It was a symphony of human cooperation, a reminder that in the face of the vast, wondrous unknown, our greatest strength will never be a single powerful eye, but our shared unwavering curiosity and our profound ability to see together. When these travellers pass through our home, it is only natural to feel a deep, almost primal urge. We want to reach out. We want to touch them. It is the curiosity of the child seeing a strange butterfly float past the window, but on a cosmic scale. This is the dream of interception. The dream of sending a probe, a robotic ambassador, to chase down one of these messengers, to fly alongside it, perhaps even to land upon it, and most incredibly of all, to bring a tiny piece of it back home to Earth, to hold in our hands a physical piece of another solar system. But as with so many grand cosmic dreams, we awaken to the harsh, cold light of reality. The challenge is immense, perhaps the greatest we have ever considered. The first and most difficult barrier is speed. These objects are not strolling through the neighbourhood. They are screaming past us at velocities we can barely comprehend. The Visitor 3i Atlas, for example, was clocked moving at 58 kilometers per second relative to our Sun. 58 kilometers every single second. To put that in perspective, our fastest spacecraft ever launched the New Horizons probe that gave us those stunning images of Pluto travels at about a third of that speed. It is like trying to catch a speeding bullet with a bicycle. The sheer amount of energy required to catch up is staggering. To match its spin and trajectory, a probe launched from Earth would need an incredible acceleration, a push that is simply beyond our current proven technology. We call this required change in velocity delta V, and the delta V needed to catch an interstellar object that is already moving so fast is astronomical. Our best chemical rockets, the magnificent pillars of fire and thunder that lift us from Earth, do not have nearly enough fuel for such a chase. Our incredibly efficient ion engines, which push gently with streams of charged particles for years, are far too slow to catch something that is already so far ahead and moving so quickly. Even theoretical propulsion systems like nuclear rockets, which we have dreamed of for decades, would be stretched to their absolute limit to even attempt such a pursuit. And then there is the problem of time. By the time our telescopes spot one of these dim, fast-moving visitors, it is already in our cosmic front yard, and by the time we confirm its path, calculate its orbit, and realize with a shock that it has come from another star, it is often already on its way out. It is disappearing, heading back into the endless dark. A robotic mission, even a simple one, takes years, sometimes decades, to design, to build, to test, and to launch. We cannot simply point a rocket at the sky and go. We had no warning for Oumuamua. We had no warning for 2i Borisov. They were here, and then in the blink of a cosmic eye they were gone. We were left standing on the shore watching a mysterious ship disappear over the horizon, wondering what secrets it held. But just for a moment, let your mind drift. Let us set aside the impossible physics. Imagine a future where we were successful. Imagine a small protected capsule glowing red from its passage through our air, parachuting gently down into a remote desert. Inside is a tiny grain of dust, a chip of rock from another star system. What secrets would it tell us? Scientists would take it to a shielded cleanroom, a laboratory kept pristine from all earthly contamination. They would first analyze its isotopic fingerprint. Isotopes are different flavors of the same element, and the exact mix, the precise ratio of one to another, is a unique signature of the stellar nursery where it was born. For the very first time, we would hold a chemical return address using a fingerprint from a star system hundreds of light years away. We could learn if its parent star was like our sun or something vastly different. They would look for complex organic molecules. These are the carbon-based structures that form the building blocks of life: amino acids, sugars, and lipids. Are these pre-biological molecules common across the galaxy? Are they delivered by objects just like this one, seeding young planets with the raw ingredients for life? We would be looking at the recipe for life delivered from a completely alien kitchen. It would tell us if the chemistry that led to us here on Earth is a lonely miracle or a universal chorus. And finally, we would date the minerals. By measuring the slow, predictable decay of radioactive elements trapped inside the rock, we could learn its precise age. Is this object older than our own sun, a relic from the galaxy's youth? Is it a young fragment from a star that has only just formed? We would be holding a clock, a timepiece from an unknown place, telling a story that began long before our own world even existed. It would be perhaps the single most profound artifact ever held by human hands. The dream feels impossible, but we are a species that learns. The passage of these visitors has taught us a valuable lesson: you cannot prepare for a surprise unless you are always prepared. This has given rise to a new and brilliant idea, the rapid response mission. The concept is simple but elegant. Instead of waiting to see a target and then building a mission, you build the mission first. You design a spacecraft specifically for this purpose, fast, nimble, and above all patient. And then you launch it. You send it not to any specific destination, but to a quiet, stable point in space, perhaps at a location we call a Lagrange point, where it can orbit the sun alongside the Earth using its solar panels to stay awake, listening and waiting. It becomes a sentinel, a watchdog lying in wait. For years it might do nothing but circle in the dark, a silent hunter. But the moment our network of powerful new telescopes on Earth spots the next intriguing visitor, the message is sent. The spacecraft awakens, its powerful engines ignite, and it begins the long chase, already in space, already prepared with a crucial head start. This is not science fiction. The European Space Agency, ESA, has a mission in development right now called the Comet Interceptor. Its goal is to do exactly this, to wait in space for a pristine long-period comet, one that is visiting the inner solar system for the very first time. And if an interstellar object should happen to fly by on a path it can reach, that would be the ultimate prize. This is the new model. We are learning to be patient. We are designing missions for targets that we have not yet discovered. We are setting a trap not of aggression, but of pure curiosity. So while we missed Oumuamua and we missed Borisov, we have learned. The dream of interception is still alive. It has simply changed. It is no longer a frantic chase, but a patient vigil. The next time, and there will be a next time, we may finally be ready. We will be waiting in the quiet dark, prepared to welcome the next messenger, and to finally reach out and touch the stars, and so the encounter is over. Our fleeting visitor, 3 Armies Atlas, is once again receding into the quiet interstellar dark. It is growing dimmer with every passing moment on its way back to the void it called home for millennia. It was a brief spark in our skies, a momentary guest that crossed the threshold of our solar system, stayed for a short while, and then continued on its endless journey. But it left something behind. It didn't leave a physical trace, no dust or debris or debris. Instead, it left a legacy. It left us with new knowledge, and perhaps more importantly, new and deeper questions. It shifted our perspective ever so slightly on our place in this vast cosmos. As we lie here in the quiet, let's reflect on what this messenger from the deep dark taught us. First, and perhaps most simply, it proved we could do it. It proved that we are watching. For so long we have stared into the night, building our sentinels of glass and steel, our digital eyes all pointed outward. We wondered if we would ever be quick enough or lucky enough to spot one of these travellers. The arrival of 3I Atlas was the universe's answer. It was a resounding yes. Our nets, though, cast wide, were able to catch something truly extraordinary. It proved our vigilance is worthwhile. We are no longer just guessing. We are watchers on the shore, and we have finally seen a ship from a distant land. This changes everything. It means the first one is no longer the only one. It is just the first. We will find more. But this visitor didn't just show up. It brought lessons. It challenged what we thought we knew about the building blocks of other solar systems. We are used to our local comets, the ones born here with us. They are mostly driven by water ice. As they get close to our sun, that ice turns to gas, and they create those beautiful flowing tails. Our Atlas was different. It felt alien. Its engine was not water. As we watched it, as it felt the first warmth of our sun, it came alive. But it was powered by something else. The fingerprints in its light pointed to frozen carbon dioxide, the gas we breathe out. In the impossibly cold depths of interstellar space, this dry ice can be the main engine. As it warmed, jets of carbon dioxide burst forth, pushing the object steering it, giving it a faint, ghostly life. This simple fact taught us that our models were incomplete. We had a local view of how comets work. 3I Atlas gave us a galactic view, showing us that in other colder nurseries things are built differently. And that brings us to its very substance. What was it made of? When our instruments tasted its faint reflected light, they found a recipe that was both familiar and strange. It had the basic elements, the hydrogen, the carbon, the oxygen, the same things we are made of. But the proportions, the chemical mix, was not from our neighbourhood. This is the heart of its message: diversity. The galaxy is not a uniform factory stamping out identical planets and comets from a single mould. It is a vast creative garden. It is a collection of 100 billion unique laboratories, all running their own experiments. This object was a single grain of sand from a beach we have never seen. Its unique chemical fingerprint is a testament to the sheer beautiful and endless variety of the cosmos. Perhaps the most staggering realization was its age. We are used to thinking of our sun as ancient 4.5 billion years old, but the clues embedded in 3I Atlas suggested it was a relic from an even earlier time. It may have contained grains of dust, tiny pristine particles that were forged in the atmospheres of stars that died before our sun was even born. Think about that for a moment. This object was a time capsule, see, it was carrying the physical memory of a pre-solar universe. It was a piece of the cosmos's older generation drifting silently through space to eventually float past us, the newcomers. We held for a brief moment a piece of history far older than our entire world. It's a humbling thought, isn't it, that the universe has such a long memory, and it sends us messengers from its deep, deep past. And within that ancient alien mix, we found something precious. We found the components of life, not life itself. No, but the ingredients, the complex organic molecules, the very same types of molecules that on our own young world billions of years ago came together in the warm primordial oceans to form the first life. To find these prebiotic chemicals in a visitor from another star system is one of the most profound discoveries we could ever make. It means the stuff of life is not special to Earth. It's common. It's being forged in the clouds between stars. It's being frozen into comets and asteroids, and it's being delivered like a cosmic seed from one system to another across the galaxy. 3i Atlas was a messenger telling us that the potential for life is written into the fabric of the universe itself. The seeds are everywhere. And yet, for all that it taught us, 3 Atlas leaves us with a deep resonating silence, a silence filled with new and perhaps unanswerable questions. We will never know with certainty where it began its journey, Cassini. We can trace its path backward, pointing to a general direction in the night sky toward a distant constellation. But that's all. We are pointing at a ghost, a region of space millions of years in the past. The star that flung it out into the dark. It could be anywhere now. It's a message in a bottle with no return address. This leads to an even more haunting thought. Does its home system, its family of planets, even exist anymore? It has travelled for so long, millions, perhaps hundreds of millions of years. In that vast span of time, the star that gave it birth could have run its course. It could have exploded in a supernova, or it could have expanded into a red giant swallowing the very worlds it once nurtured. 3i Atlas might be an orphan, the last surviving fragment of a solar system that is now just a memory. Or perhaps its home is fine, a stable star warming planets we can only dream of. We will never know. And now, where is it, our brief visitor? It is leaving. It is moving back into the great dark, following the silent, invisible curves of gravity. It is dimmer today than it was yesterday. Soon it will be beyond the reach of our most powerful telescopes, invisible once more. It is returning to the interstellar night, carrying our observations, our curiosity, and a tiny bit of our sun's warmth onward. It falls quiet again. We are left behind on our shore, watching the emptiness it left. But we are changed. We know now that the ocean is not empty. We know the galaxy is full of differences, full of history, and full of potential. And we know that we are not just waiting anymore. We are watching, and we will be ready for the next one. And so our long journey together, a journey taken with our minds and our sense of wonder, comes to a gentle close. We have drifted past the rings of Saturn, watched suns be born in glowing nurseries of gas, and stood at the very edge of the ultimate cold silence. We have asked the biggest questions, and we have found comfort, not always in the answers, but in the vast and beautiful mystery of it all. Perhaps the greatest journey we have taken is not across space, but across time. It is the journey of our own understanding. Think for a moment about our ancestors. Imagine them huddled together on the same spinning planet under this same vast dark sky. When they looked up and saw a new star, a bright visitor with a long ghostly tail, what did they feel? They felt awe, yes, but it was an awe laced with fear. That comet was not a ball of ice and dust. It was an omen. It was a sign from distant powerful gods, a predictor of plagues or the fall of empires. The sky was a storybook they could not read, and so they filled in the blanks with their fears. They felt small and the universe felt like a threat. Now think about us, here, in this quiet moment drifting towards sleep. We look up at that same dark sky, we too feel small, we too feel awe, but something profound has changed. Our gaze has sharpened, our understanding has deepened. We are no longer just passive observers afraid of the lights in the dark. We have become explorers. When a visitor crosses our solar system, we no longer see it as a warning. We see it as a puzzle. We see it as an opportunity, a message in a bottle from a distant unknown shore. We have built incredible eyes of glass and metal instruments that can taste the very light of distant stars and listen to the ancient whispers of the cosmos. We can point these eyes at a traveller from another star system and ask with real hope of an answer, where did you come from? What are you made of? What story do you carry? This is the beautiful quiet evolution of consciousness. We have transitioned from fear to curiosity. We have moved from seeing comets as divine angry omens to studying them as chemical messengers from other solar systems. We have seen them, we have given them names. Oumuamua, the long, strange traveller tumbling end over end, a dark shard from a place we will never see. Borisov, a comet that brought with it the chemical signature of a sun that is not our own. We didn't hide from them. We pointed our telescopes, we collected the light, and we marvelled. We marvelled at the sheer undeniable fact that the universe is connected, that pieces of other worlds can and do visit our own. This change in perspective from terror to wonder is perhaps the most beautiful story of all. This realization of connection is not just a passing thought. It is not poetry, though it sounds like it. It is the central physical truth of our existence. We have spent so much of our history feeling separate. We drew lines on maps, we built walls, we defined ourselves by what we were not. We are not that animal. We are not that other tribe. We are not the cold, dead rocks of space. But the universe quietly, patiently tells us this is all wrong. The cosmos does not believe in walls. We are not separate from the universe, we are the universe. We are a part of a grand, unfolding story. It is a story of movement of cycles of shared material. The atoms in your body, the very ones that are listening to these words, are a testament to this story. The carbon that forms your cells, the calcium in your bones, the iron in your blood, none of it was made here. It was all forged, created in the impossibly hot, pressurized hearts of stars that lived and died billions of years ago. Stars that in their final moments exploded, scattering their precious heavy elements across the galaxy. They seeded the next generation of stars and planets. Our sun, our Earth, and ultimately us. We are the children of long-dead stars. We are in the most literal and scientific sense stardust. And this story of connection doesn't stop with our own solar system. We used to think our sun's family was an island isolated in the vast dark ocean of interstellar space, but it is not. The galaxy is a bustling, dynamic place. Stars are constantly moving, interacting, and matter moves between them. A visitor like Oumuamua is a profound reminder of this. It is a piece of another world, a world that orbits another star hundreds or thousands of light years away. It travelled perhaps for millions of years through the cold, empty dark, and by pure wonderful chance it drifted through our little neighbourhood. It is a handshake across the galaxy. It is physical proof that we are not alone in our makeup. The same laws of physics, the same chemistry, the same elements that built our world also built that world. We are connected. The universe is not just a collection of separate, lonely objects. It is a single, vast, interconnected web. The matter that makes up you and me will one day, far in the future, be scattered back into that web. Perhaps it will become part of a new star, a new planet, or even a new thinking being. We are a momentary, beautiful arrangement of ancient travelling atoms. We are a way for the cosmos to know itself. As you lie here on the very edge of sleep, let this feeling of connection settle over you like a warm blanket. You are not small or insignificant. You are a vital part of this ancient, enormous, and wondrous universe. You are the eyes that see its beauty. You are the mind that comprehends its vastness. And you are the heart that feels its mystery. This is not the end of the story. It is, and it always will be, just the beginning. The universe is always speaking to us. It speaks in the language of light, in the silent pull of gravity, and the quiet passage of an interstellar comet. So as you drift off, make this quiet promise to yourself. Keep looking up, keep wondering, keep asking questions. The night sky is not a static painting. It is a dynamic, living ocean full of currents and travellers. The next visitor is already on its way. Right now, a piece of another world born under another sun is speeding through the dark unknown to us. It is coming. And who knows what secrets it will bring? What new story will it have to tell? Let your curiosity be your guide. Let your wonder be your pillow. You are a child of the cosmos, connected to everything. Rest now, sleep well, and continue to watch the skies.